close it right away, good? That's why it's
All right. Hello, everybody. Thanks for joining us this morning. Just wanted to make sure that everybody's on mute on your end. We'll have a couple of presenters remotely speaking, possibly. So at that point in time, we'll chime in and we'll control it from on our part to make sure that their voices are heard. But without further ado, I'm going to let Mike Trojan take over and moderate the workshop.
Okay, good morning everybody, and welcome to Minnesota Stormwater Manual Updates on stormwater pretreatment practices. Did I do that right?
Let me click.
We'll click on the button.
There we go. Okay, so I'll be doing some moderation today, but my part's pretty short. We have a pretty full agenda, so we're going to move along real quickly here. My contact information is there at the bottom, and if you want to get into the Minnesota Stormwater Manual, probably the easiest way to do it is just do a Google search on Minnesota Stormwater Manual, and that should pop up as your top query item. So today we've got several great speakers. I'm really looking forward to this. Forrest Kelly from Capital Region Watershed District, Dr. John Gulliver from the St. Anthony Falls Lab and University of Minnesota, Dr. Andy Erickson, St. Anthony Falls Lab, University of Minnesota, Katie Thompson from RESPEC, and Dr. Scott Struck from Geosyntec. I haven't had this many doctors around me since my prostate surgery. Hopefully this webinar will go better than that did. So if you have questions, please use the chat box. Again, please make sure you're on mute. We do have the ability to mute people, but we have to do it individually. It's kind of a pain to do that. So all questions and answers will be posted on the webpage called Stormwater Manual Webinar. So if you're in the manual, just type that in the search box and it'll take you right to that page. We are recording the webinar. It will be posted in the manual, as will the PowerPoints for from today. We are offering 1.5 professional development hours. You can access the certificate to that on that Stormwater Manual webpage. It's kind of a self-policing thing. There is a note in there saying that we do keep attendance, so if at some point you do get checked, we do have that on file here. But otherwise, just go and download the form and fill it out, and you're good to go on that. So today, Forrest Kelly is going to talk about, give a very a brief local perspective on pretreatment, and then I'm going to pass it on to Katie Thompson, and she'll introduce our speakers. Andy's going to talk about pretreatment filter strips. Scott's going to talk about pretreatment practices and a pretreatment selection tool that we're actually pretty excited about. John is going to talk about pretreatment sizing recommendations, and then Katie will wrap up with some case studies, and then at the end I'll just kind of tie everything together. I'd like to thank our tech team members who supported this work by reviewing materials, communicating with us, providing us with case studies and so forth. Jesse Carlson, John Lenander, Ross Bintner, Joel Mulcahy, Noah Check, Forrest Kelly, and Haley Bauer, who was project manager for part of this work before she decided Southern California was a better place to live in Minnesota. So, real quickly, why pretreatment? Pretreatment's important. It reduces the maintenance frequency and severity and cost. We've been anecdotally hearing that pretreatment might be one of the reasons why some of our primary BMPs aren't performing the way we would like them to perform. And prior to all this work with RESPEC, the manual was pretty lacking in pretreatment information. So we're pretty excited that when this last work order is done at the end of this month, that the manual will be will have some pretty solid information on this particular topic. And so with that, I'm going to introduce Forrest as our first speaker. Now, Forrest is speaking remotely, and I don't believe he has anything to present, but I just wanted to make sure we had a local perspective, an actual stormwater practitioner who works with pretreatment. So Forrest received his BS in Biosystems and Agriculture Engineering from the University of Minnesota. He began his career in water resources chasing sediment as a construction stormwater site inspector with the Ramsey, Washington Metro Watershed District. He has been with the Capital Region Watershed District since 2007 and is Regulatory Division Manager, and he is a registered professional engineer. Forrest, I'm going to pass it on to you. Keep my fingers crossed that all our technology works now.
All right, thanks, Mike. Can everyone hear me?
Yep, great. We can hear you.
All right. So yeah, I apologize in advance. I don't have any visual aids here. Mike assured me that just the sound of my voice would keep everyone entertained, so hopefully that's true. You know, I've been coordinating permit reviews almost since Capital Region's rules were adopted, so I don't necessarily consider myself an expert, but I guess I've been around long enough to have learned some things. You know, our rules say runoff must be pre-treated, and that's it. So what does that mean? I think we included that vagueness on purpose at first. I know the NPDS construction permit gets a little more prescriptive in offering a list of pretreatment practices that you could use. But I think we've been doing this long enough that maybe we need some more prescription to what is enough pretreatment. So I'm really excited about this additional information that's gone into the manual. You know, initially, pretreatment was a catch basin with a sump, and that was it. And they say, well, we've provided pretreatment. And then it turned into a sump with a hood or something to capture floatables. We've seen as little as a strip of sod between the pavement and a rain garden on a street project. So we've been learning what works and what doesn't. So hopefully none of those practices that don't work are in the manual as recommended practices, but as the state of the practice has evolved, we've seen swirl separators go from just a large manhole with a pipe that comes in at an angle to get that water swirling around and drop out the sediment. Now I think all the swirl separators, the proprietary devices, they've all got some sort of baffle or chamber to hold on to that sediment so that it doesn't get resuspended. That has been an issue that we've seen a lot, is that you can capture that sediment up until a certain point, but then you get a big storm and the sump is full and it all just washes back out, gets resuspended, and now it's in your BMP. You know, I've also had the privilege of working on some of our capital improvement projects and stewardship grant projects. We've learned a lot on implementing pretreatment on street projects. Again, our Arlington Pascal projects in St. Paul did a lot of boulevard rain gardens, and we started out with a grass strip to provide pretreatment, and we found that over time that grass grows up above the curb line, and then water can't get into the practice, and then you're replacing the sod. So that design evolved. We cut out the sod. We added some those rubber mats that you see in restaurants to help ease your back. Clean those out very often. Those didn't work. And now we've got some paver stones. One critical thing is that what we've found is you have to have that initial drop below the grade line of your curb so that water can get in no matter what. Another area that we've seen some failures is on, and an evolution of pretreatment practices is on the green line. We installed side street rain gardens along the University Avenue corridor for the Green Line project when that went through St. Paul. And we've seen some deterioration of the Kasota stone sumps that we've provided. So making sure that the materials that you are specifying for these practices can hold up to winter, the freeze-thaw. You know, they're almost always going to be wet and collecting sediment and leaves, so that's a key aspect to think of when you're designing some of these projects. You know, I think Pretreatment has to do a minimum of 3 things. It's got to be easily accessible. It has to confine your maintenance practices to a specific location that is smaller than the BMP that you're trying to protect. And then it's got to reduce the maintenance frequency of the BMP that you're trying to protect. I think it should also be designed so it prevents bypass when it's full, because none of these pretreatment practices are going to work right unless they're maintained. And with personnel and budgets being tight, we know that a lot of these practices don't often get maintained as much as we would like or they should. So if there's a way to design these so that if that maintenance frequency goes a little bit beyond where the recommendation would typically be, that water is still allowed to get into the practice so that the BMP is not totally offline and we're not getting that treatment that we are expecting. So, there's no one-size-fits-all pretreatment practice out there, which I think is why the regulations have been vague for a while. There's underground BMPs, there's surface basins, there's space constraints, large drainage areas, small drainage areas, and we've struggled with, is there a numerical standard that you could provide? You must capture X% of X micron particles, but we haven't determined or settled on, pun intended, what that proper requirement is. So we're really looking forward to implementing some of the guidance, taking a deeper dive into what's provided in the manual here, and seeing how we can maybe incorporate that at least into our reviews for permits on projects that disturb an acre, and maybe even incorporating some of those recommendations and guidance into our rules. That's really all I have.
Okay, thanks, Forrest. We really appreciate it. A couple things before I know Forrest has got to head out, so if you have questions for Forrest, please send them to us, and we will, I'll communicate with Forrest, and we'll get those answers to those questions posted in the manual. Also, Forrest, you mentioned a couple things that I'll take note of. John, we'll be talking about sizing later, and you talked about that. Also, anybody who's online, if you have case studies, experiences with pretreatment, please send them to us. We'll take a look at them, because we're always looking for good information to put into the manual. And Forrest, if you can hang on for just one more second, I got a real quick question for you. In what you're talking about, you seem to allude to the idea that there's a lot more and more pretreatment options coming online, and would you say that that's true, and is that a good thing or a bad thing?
Yeah, I do think that's true. I think it's a good thing. More options is always a good thing, I think, as long as they're good options. I think a lot of the manufacturers have seen the need for pretreatment, so that they're ensuring that their products that go in the ground are viable long term. So there's isolator rows and internal baffles and weir walls in these systems. So and even all of the I'm thinking of the larger swirl separators. There's so many options out there that some of them get very expensive, some of them get really huge too, but those options are out there, and the technical assistance from a lot of those companies is very good. And there's a lot of I know Shazam has been out there for a long time, and guidance on how to size those. So I do think it's good that there's more options out there, and a couple of options have maybe fallen off the table, and that's a good thing too.
Forrest, I really appreciate you joining us this morning, and I always appreciate your experience and expertise. So, again, thanks, and I'll be in touch with you probably sometime today later or sometime later this week. Thanks.
That sounds good. Not a problem. Thank you.
Okay. Yep, take care. So at this point, I'm going to pass it on to Katie. One thing, just a real quick follow-up with Forrest mentioning about the number of pretreatment practices. I'm really excited about that pretreatment selection tool that Scott's going to talk about later, because when RESPEC sent me this table with 1,000 different practices, I thought, oh my God, how are you going to pick the right one? And so that's why we had them develop this tool, and it's pretty nifty, I think. So, Katie, I'm going to pass it on to you. I'm not going to introduce you. I'll let you introduce yourself later, but you'll take it from here, basically. And do you need the...
I
do you need
think
that?
the clicker, yeah.
Okay, so Katie Thompson from RESPEC, who is the project manager for RESPEC on this, is going to introduce the speakers from this point forward.
Yeah, thanks for having us here, and thanks to everyone for attending our webinar today. I'm Katie Thompson. I'll just move past this. Katie Thompson, I'm the project manager. I've been working on the pretreatment case studies and pretreatment sizing with Dr. Gulliver. We also have Dr. Scott Struck here from Geosentech, who will be presenting on the pretreatment selling practices and the BMP selection tool that they developed. Dr. John Gulliver, as I mentioned, will be doing the pretreatment sizing, and Dr. Andy Erickson will be discussing filter strips and the Stormwater Manual Update that we've been working on prior to this most recent update here. And with that, I'll turn it over to Andy real quick.
Very good. Good morning, everyone. My name is Andy Erickson. I'm glad to be here with you today to talk about some of the work that we did previously on pretreatment. Part of that work is we wanted to develop an overview of pretreatment, which covered not only the importance of pretreatment, which Mike talked about in the very beginning of this, but the different methods and the practices specifically, which kind of fall into three categories: settling devices, screens, and vegetated filter strips. In that work, we developed some information, or pulled some information in from over 30 references on cost considerations, applicability of these different devices, as well as compatibility with downstream structural stormwater BMPs. Part of the work you can see on the right side of this slide are some graphics and some pictures we pulled in as part of that. One of the main graphics on that first overview page is really what we're trying to target with pretreatment, which are essentially the large particles, the gross solids, the large sediments, down to really only about 100 microns. And that's really what we're trying to target with this. If we need more capture of sediment, we need to get into a structural stormwater BMP or even potentially advanced treatment. We did go into some detail on the individual categories as part of that work. Settling devices, we really presented some information on a lot of different categories: processes, what's happening in these practices, applicability and suitability in cold climates, retrofit conditions and ultra-urban situations. Also, there are links there to other parts of the manual related to permits and applicability there. We discussed advantages, limitations, water quantity treatment, which is really volume reduction. For these settling devices, typically we don't have volume reduction, but we do have water quality treatment in terms of performance for removing sediments and other pollutants. For settling devices specifically, we also have a section on certification programs, because there are certification programs and systems kind of across the country. And so we wanted to present that so that people were aware of those and could look for those if they're interested. Again, on the right side of all of these slides, I have some pictures and images from these individual sections. You'll also find at the end of each of these slides links to the individual pages on the Stormwater Manual where you can find all of this information. And these slides will be provided on the manual after this. We did the same for pretreatment screens. Again, all the same categories that we talked about. There's information here related specifically to screens and a link for that, as well as some images for different types of screens that we see for pretreatment. And finally, vegetated filter strips with some images and a link here. Again, the same categories, although for vegetated filter strips as part of that work order, we did dive a bit deeper, and we pulled up some more, oops, went too fast there, pulled up some more references, over 20 more references to talk about specifically design, construction, operation and maintenance of these vegetated filter strips specifically for pretreatment. And so we did talk about design criteria, construction specifications, and operation and maintenance. And you can see here just a couple images that we pulled together for that work, and again, a link to all of that information. So all of that is all currently in the manual right now. That's kind of a short summary of the work that we did and pulled together for that as a lead-in to the work that we're talking about today.
All right, so this is Scott Struck with, did you, do you want it?
Don't listen.
Okay. This is Scott Struck with Geosyntek. I'm going to follow up with Andy's discussion and talk about the pretreatment settling practices and the pretreatment selection tool, and then even do a quick demonstration of that. So as Forrest had mentioned, that pretreatment is a requirement of the construction general permit, so it's covered under that permit and is a requirement of that. We're talking about a little bit more on the stormwater side, in that Forrest had mentioned how it was more of a descriptive type of standard that must be met, and that I think is good in that it allows some flexibility with it right now. But overall, as Mike had said before, our objective here is to provide some guidance. Andy just went over some of that information of the design criteria and the considerations, some of the construction guidance, maintenance recommendations for these different pretreatment controls. And Andy already hit on this, the three different types of general practices are the settling devices, screens, and vegetated filter strips. We've taken that and we've gone into a little bit more of an analysis of the functional processes of these. So we've ordered these in the pretreatment section under the different processes, which include hydrodynamic separation devices, or swirly devices, as they're referred to, screening and straining devices, above ground and below ground storage and settling systems, filtration practices, and then we have a few that don't fit in those typical descriptions that we've put under the other water quality devices, kind of a catch-all. The organization of that part is providing each of the different types of pretreatment practices in those different categories, and then each of those sections provide a pretreatment overview, a process summary, and pollutant removal, system design and sizing information, and then installation recommendations, inspection, and operation and maintenance. And so that is all coming from the information that Andy was describing of what's in the manual. We've taken that, essentially that same kind of information and brought it in for the pretreatment. The other side of that, and this is mentioned a few times, is that a number of the devices are proprietary or are manufactured, and so we have numerous references back to those manufacturers' websites or some of the assessment websites, which Andy referred to, the national certification programs. And so there's a number of references that go back to those types of information, because it's very useful both in the citing and the design and expectations for performance. So this is a screenshot of what the pretreatment page looks like. This is a section from that hydrodynamic separation devices page. And I pulled this one up mostly because it has some of the information that's already been referenced, including Shazam, reference to the link out to Shazam for that, the link to, for instance, the New Jersey Department of Environmental Protection, which provides one of the certification programs. And so you'll see that there's a lot of this information that's directly hyperlinked within the text there, so that it really is, the information is at your fingertips. And I'm going to follow through the hydrodynamic separation devices as an example of the type of information, and then demonstrate that it's really there for all of these categories. So again, you see the quick kind of information in terms of an introduction, the system and component sizing, installation and maintenance recommendations, and then there's some O&M that connects to a number of different tables. So this is an example of one of the tables that it connects to. This is specifically the information on just the description, the general descriptions of the different types of devices. So this covers, for instance, the treatment mechanisms and general pollutants removed. Next section includes information on the system sizing, design information, and we've included information like the typical land use where it's applied, compatible downstream practice, Some of the sizing calculations, especially on the hydrodynamic separators, this is where it often refers out to the manufacturer's sizing tables and information such as that, as well as other aspects of the designs that are important. For instance, the inlets and outlets tend to be a real important factor on these, and whether they're designed properly or constructed properly, and then flow diversion structures. Forrest even had mentioned in his introduction about preventing bypass with pool and things like that. So those diversion structures are pretty important for this as well. Continue on with the type of information that's in there. The installation recommendations, inspection, and operation and maintenance. We have a table that includes that type of information, including inspection frequency, the typical kind of maintenance that's needed, whether there's different public or private considerations, and then ways that you can potentially minimize some of the maintenance and some cost considerations as well. Again, you'll notice from this screenshot of that table that we have hyperlink text that go out to manufacturers' recommendations. In addition, as Andy was indicating, there's a lot of citations for a lot of the information in there, and we've included a lot of linked references for that also are hyperlinked, that are accessible to everyone using the tool as well. With that, we have these numerous tables that help really kind of sort out and think about how these practices work and the way that you might select or decide between each of these. And so with this, we have links to numerous tables. I think Mike was really thinking ahead on this when he decided that we should have a single page with, for instance, all of the information on there. So we have this link to all these tables, as I was just showing. We have a link that has all of those on a single page, for instance, where you can look at the comparative parts of each of those factors. And we have an Excel sheet that you can access it in as well. And then lastly, we have individual tables themselves. So for instance, the tables that are just on more the summary and pollutant removal characteristics, the design information, the sizing information, and then installation maintenance recommendations. So it's packaged in multiple ways so that you can look at different aspects of each of these pretreatment practices and get an understanding or even hone in on the aspect that you're most interested in without seeing a lot of other additional information if you don't want to. So this is just an example of the screenshot for the screening and straining devices, as we've called them on this, and then the above and below ground storage and settling, and then filtration devices and practices. And as I mentioned, we had to kind of catch all the other pretreatment water quality devices, and that included things like floatable booms and snouts and hoods and so forth. We go through and you can see on this page we indicate whether there's proprietary or non-proprietary type of devices out there, so that if you are looking for a manufacturer, you can know whether it might be available. And then if there is something that you desire that's not from a manufacturer, you can consider something like that. So I'll now transition over to the pretreatment selection tool, and I have some screenshots of the tool, and I'll try to go through those quickly, and then hopefully Charles will allow me to do a little surfing with this, but I'm going to go through the screenshots first, just to show you what it's like and give a quick introduction. So this is the landing page, and it has a couple links here, the pretreatment practice selection tool, and then the pretreatment practice info, which actually just takes you back to the MPCA page on pretreatment. So when you click on that, the lower left link there, you go to this page, which allows you to select different factors that we are filtering those different practices on. As Mike was mentioning, that we have a population of about 40 practices in here right now, and so it can be confusing, especially for new users and even educated users, on ways that they might want to select a particular pretreatment. And so we've gone through with the team and decided on essentially 4 major factors that are probably the most common type of factors where the user might want to determine which practices meet those different characteristics. And so we've sorted those out by general pollutant type, the downstream BMP protected, so that compatibility of downstream or primary BMP systems, the approximate drainage area, and space requirements is the last one. So as Forrest had indicated before, some of these practices can get quite large, and if you're looking at that footprint, it can also be an above-ground footprint or it can be a below-ground footprint, and those can differ. And so, depending on your space requirements, you might have a need where the above-ground footprint is rather small, but the below-ground footprint can be larger. So that was another category or factor that we thought would be useful for being able to sort the different pretreatment types of devices. So to give you an example of the way this works, here's the general pollutant type. If you were to click on anywhere on that bar, and this is the little menu that pops up, and you can see that we've put these in general categories. So one of the more challenging parts of developing the tool is we wanted to be sortable, but we wanted to put it in general categories that weren't that were somewhat defined, but weren't completely defined. And some of these practices, in fact, many of the practices will capture multiple different pollutant types. So we've just put them into this mineral and organic solids and floatables, or mineral and organic solids is one category, floatables is another category, oil and grease as a third category. And then you'll notice that the top one where the blue button is right now is blank. And the reason for that is that we maintain that so that if you go back and select the blank one, it doesn't filter anything on that particular factor or filter type. So what that allows is the flexibility to choose any of these four that you see in the grayed area here. So following on that, the downstream BMP being protected, that's, again, we kind of categorize that. We could have a list of 20 different downstream BMPs, but instead of doing that, we worked on it more from the types of processes that are being used. And so it's filtration, infiltration, and storage, and then we included a few examples like detention, retention, and rainwater harvesting, and wetlands, for instance, for the storage kind of devices. The next one is drainage area, and this one, again, you can see that we've categorized it into these general terms, large, medium, small, extra small, but in the drop-downs, you'll see that we actually have defined that. So large means, for instance, a drainage area of greater than 10 acres. And we've also done some rudimentary modeling to make sure that that drainage area roughly relates to a flow rate, because oftentimes these devices, especially the hydrodynamic separators, for example, are sized more often from flow rates rather than from drainage areas. So we've included things like, greater than 15 CFS for that large as an example. And again, these are not hard and fast categories. They're more of just generalized categories for use. And then, you can select or deselect these and compare the different results when using the tool. And the last one is space requirements. I had mentioned above ground and below ground. So we have above ground large, above ground small, and then underground, a large and a small for underground. And we had to come up with some kind of size limitation for what large and small meant. We looked at a number of the practices, and it's, again, this is one of those gray areas because some of the practices have multiple sizes for them, so that these aren't hard and fast definitions, but more a little bit kind of gray definitions, but give you a way to at least sort into something that reduces the number of potential pretreatment practices there. And we found that this roughly 30 square feet is about right. Mike might say that we need to change that in the future to something either smaller or larger, but this seemed to be something that was, at least in terms of a rule of thumb, a good size to start with. Other information that's included in the results, of course, you're getting the ones that we sorted on, so the drainage area, general pollutant type, downstream BMP, and space requirements, but we've also included a category for ease of maintenance, which is one that we were originally thinking about sorting upon. We decided not to because it made it a little bit more challenging in terms of how to define those. But it was important, for instance, to maintain some of that understanding and reporting of that ease of maintenance. And so we've done that. And so here's what that results looks like. So this is just going through an example. I can run through this once I jump in the tool. But I selected the general pollutant type, and then I selected mineral organic solids that I'm targeting, and then the downstream BMP being protected. So that compatibility, I've shown an infiltration BMP, so maybe I'm thinking about putting a bioretention system that allows infiltration downstream from that. I've selected a drainage area, and then those space requirements. Let's say I'm in a more urban area, or I'm along a street corridor, so I'm within the right-of-way, and I want a small above-ground footprint. And so I've used those as my factors to sort that. And you'll notice in the results, if you've been paying attention on the previous pages, when I have it sorted, there's 38 practices that are in there total. But when I've done this sort with these filters in there, I now am down to 12. And just to give you an example with this one particular system, the Vortex device, if I click on that, it takes me to this page where I can look at all of the devices actually that are in that category, but now I have the Vortex in particular that I can look at each of the factors that we talked about before with the general information, the system design information, the component sizing, and then not shown on this is the operation maintenance and construction considerations. And you'll notice that this is what I was referring to, the table that's very tiny. I don't expect anybody to see this, but at the very bottom it has those references and so forth that are based on the footnotes. So this is my last example for screenshots. I figure we'll give it a go and trial it out. Mike, what do you think?
Might as well try.
All right, let's test it out.
Sure. And Scott, as we transition here, I know questions are kind of trickling in. Let me just say that we'll do our best to get around to questions after the presentation. And if we need any clarification, any further clarification on questions, we'll do our best to unmute that person so that they can further explain their question.
Great, thanks. And that's a great point. I forgot to mention, Chal, when I started this, that in terms of that actual tool being built, I am not that person that does that. Dan Pancani, my colleague, is here, and he's on the call as well. So if you have questions on, for instance, how it's sorting or any questions on the actual tool itself in terms of its functionality, I've got Dan on the line, who's my genius that helps me do those kinds of things. Okay. Thanks. I'll let you just take the mouse. So as I was saying, this is the landing page for this, and it has the two buttons here. This one just takes you back to the wiki page, but this is where we go to the pretreatment tool. And as you can see from the screenshots that I gave you before, this is what shows up. It gives you those 4 different types of filters. You simply click on one of the box, it pops up, and we can say we want to look at the mineral and organic solids. We can submit that as is. Okay, and we eliminated 4 of those particular devices, and then we can look at one of these others. Let's look at, let's say, infiltration again, submit it, and then we've reduced 4 more. Now, if you're going along, you say, well, wait a minute, I don't want to necessarily look at the pollutant type, I just want to look at infiltration. You can go back and deselect this back to that blank one like this, submit it, and it will change that. So it allows you to basically choose up to 4 of these selections, and it produces results. And as you can see, if I scroll down, here are all of those results. You can sort it on the number of pages or number that show up to 20. So again, just like your Amazon page and so forth that we go and buy things at, it has a similar type of filtration. Instead of shoes, we're going for pretreatment devices. And we're doing the same thing. Instead of size 9, I'm looking at general pollutant types and so forth. So it's set up very similar to that, so you can focus in on the types of practices that you would like to put in. So, for instance, I can go to small drainage area and submit that. You can just see how that's changing. Space requirements, I can go to an underground small footprint and submit, and you can see how the practices are being sorted, the kind of information that's produced. And then again, if I click on these links, it will go back to the website and bring you to where that section is within the pretreatment website. And you'll have all of the other previous references and so forth there. So with that, I think I'll stop. I'll give it back to Katie.
Should we do a little question break? Because I know people are sending it in through the chat, so we can take a look at that and see what they've been saying.
can go through the chats here. So we have a question here that says peak flow rates are increasing. So how is the recommendation for how to size made? Does it take into account the possible increases in flow rates due to climate change over the life of the pre-treatment installation?
If I could answer that. Right now, we are not taking into account any changes for instance, for climate change in the design. That's typically a design standard. My experience across the U.S. is that some places are essentially oversizing designs now based on considerations for, and it might be actually not just oversizing, but undersizing. Some locations are including climate change factors into their sizing for future infrastructure, and some places aren't.
To some extent, if we're sizing our permanent practice and adjusting that to what we're seeing in terms of changes, would that be linked in some fashion to some of the pretreatment sizing?
Sure, and I think, I mean, I'll defer to Dr. Gulliver on this, but I think we have to go back and remember what is the purpose of the pretreatment. It really is trying to reduce the maintenance requirements and the functionality and performance of that primary practice. And so it's not intended to replace the practice. It's intended to be a place where we can easily maintain it, we can reduce the frequency of maintenance, for instance, of that primary practice, and we can increase the longevity and performance of that practice. And so that's one thing to keep in mind for these pretreatments. They're not intended, in most cases, to actually replace a primary treatment practice. John, anything to add?
No, that was well said.
Okay, just some general things. I guess the slides are going to be made available, correct, Mike?
Correct.
I assume that's going to be on the Stormwater Manual somewhere.
Were there any other questions on there?
Yep. What exactly is the rational rainfall method?
Yeah, that one, it's a methodology that's been developed based on empirical evidence that relates different impervious surface amounts to the amount of runoff. There's a lot of information if you just Google rational method for sizing. There's copious amounts of information for that, and there's different methodologies for doing a rational method.
And there is information in the manual also on the rational method, oftentimes called simple method too. So it has a couple different names that you come across, but yeah, you just do some Google searches if you're in the manual, look for it in the manual, and you can find tons of information on that topic.
All right, next question. Is there a pre-treatment option that helps remove chloride, like road salt?
We've talked about this, and generally not, because it's a dissolved ion and doesn't really react with things. We are doing research on chloride right now related to road salt and trying to find some better ways to deal with it, but there's nothing, at least nothing in the selection tool I don't think relates to chloride, right? So, nothing yet.
Would certain practices delay the response though? For example, a filter strip or a 4-bay, that's still going to be a conservative anion, but would it move a little bit slower through the system maybe, if that would be a potential way of managing it?
Right, anything that would delay the flow and attenuate the peaks or slow down the volume will change how quickly the chloride moves through the system. And anything that infiltrates will change where the chloride goes versus surface water versus groundwater. But
you need a big practice.
But you would need a big practice.
You would need a
storage.
lake, really. 10 acres or more, something like that.
Okay. I think this next question is probably for you, Dr. Struck. For peak flow areas, what storm event does this consider? An example, if the peak flow is 2 CFS, is this for the 10-year event? How is this correlated with the drainage areas?
That's a good question in that we weren't necessarily associating each of these with an event. It was more looking at, well, I think when we did the sizing, we essentially did a standard 1-inch event as, roughly representing, the 85th percentile of events that happens in most places, and then looking at a particular impervious area, and then developing those flow rates off from that information. Now, again, I'll caveat that with these were just rough estimates to give the user some ideas that would kind of filter within the different types of practices. Many of these types of practices, especially again if you're talking about the proprietary devices, has multiple sizes that would be sized, again, based on using Shazam or the manufacturers and the manufacturer's information for those. For the non-proprietary devices, John, you're looking at some of the sizing factors for that. So it's trying to relate it back to that. Again, just a rule of thumb. It's not meant to be, this is my design flow for this, and this is the only practice category that I can put it in. Because remember, we're also talking about being able to handle peak flows and considerations of peak flows and that bypass and so forth. So we're not going into that level of detail for the filtering tool, but really just trying to provide some guidance to be able to narrow down into a certain set of practices that might be applicable.
We maybe take one more before moving on?
I think we're
Are we
pretty
done
good
on
on time, so.
Pretty good? Okay.
Yeah, we can probably, if there's more than that, we can go ahead and try to address them now.
Okay, sure. Next question we have here is addressing cost estimates. Does the information added to the manual include approximate cost estimates for different pre-treatment systems?
What's currently in there, in terms of what I was talking about previously, cost considerations on the previous work, that was taken from estimates that was out there available. There wasn't a lot of cost information at that time, at least, available. There may be more now, but it did try to collect as much information as was available.
We've tended to shy away from putting cost information in the manual. One place that you will see it fairly frequently is in some of the case studies. So when you see a case study, we try to get the cost information for that. And so I'll just reiterate and circle back to what I said earlier. If you have case studies and examples and you want to send that to us, we'll take a look at them, and please do include cost information. One of the reasons we've shied away from cost information is because it's like a car. You pay so much today and you drive it off the lot and it changes the next day. So it's really a moving target.
Okay, the next question we have is, will a recommendation be established for a particle size distribution and percentage removal for TSS?
Do you want to address that, John?
Sure, okay. Yes, you can't remove a whole distribution or even a part of the distribution, mostly because the distribution changes with different storms. You have a big storm, you have a very coarse distribution, and when you have a small storm, you have a very fine distribution. But if you specify the size of the particle and the percent removal that you want to have for that particle, then you can size your practice. And that's what I'm going to talk about in a little bit.
Thank you. Should pre-treatment be credited toward pollutant removal requirements? And the example given here is the MIDS recommended TSS and TP removals. Do the pollutant removal efficiencies listed in the Stormwater Manual include pre-treatment?
The assumption is that pre-treatment will have been done prior. So the short answer is no. The removal efficiencies assume that you have already done pre-treatment, and it is a permit requirement that you must pre-treat. I know other states don't call it pre-treatment. They actually give removal efficiencies or similar types of information for some of these practices. These practices are per the permit, considered to be a permit requirement and not associated with the pollutant removal numbers that you see for the permanent practice. I suppose I could have just said no.
But I think it gets back to as Mike mentioned in the very beginning, the purpose, and Scott reiterated as well. We're trying to minimize maintenance, limit maintenance, make that easier, ease of access. I mean, that's kind of the purpose of pretreatment. It's not meant for pollutant removal. That's not one of its primary goals. It's more about maintenance and ease of access and making longevity of the structural BMP so that it can achieve that % removal for a longer period of time.
And also to reiterate, as I'm not sure who it was, you pointed out, I believe, we're shooting for that 100 micron, and that's not going to do a lot for you for something like phosphorus, for example. Right. So many things come into play when considering pretreatment and the role of it and what we're giving in terms of credits.
Right, this next one is a good technical question. Is the drainage area per inlet? For instance, if we have several area inlets around a 10-acre development that discharge to a single detention or retention basin, would it be best to have individual pretreatment at each area inlet or one larger one serving the entire development ahead of the detention basin?
At each individual inlet would be ideal.
I would agree with that. And it has to do with how you're designing the whole system. If you have access, for instance, to, you could, for instance, have those all routed to a 4-bay and use something like that, which we have as one of our pre-treatments. But oftentimes at that inlet areas where you have the best and easiest access, and if that's the case, it would be at that inlet.
No, I agree.
And I was talking to John earlier about permanent practices, but it's a similar type of question, regional versus site types of practices, and we really promote site practices when you can. There's a number of reasons, but one of them is if you're banking everything on one practice and it fails, then you've really got a problem. And this way, if one of your little systems fails and you got a whole bunch of other ones and so forth, you're still getting some treatment. So.
Okay, great. We have one more here. Level of performance varies significantly across different pre-treatment practices. Is there a reason numerical standards were not included in the manual or tool?
Can you repeat that?
The level of performance varies significantly across different pre-treatment practices. Is there a reason numerical standards were not included in the manual or tool?
I'm not sure exactly what is meant by numerical standards.
I think it gets back to what we were just saying, the purpose. We're not trying to achieve a certain % removal of particles or phosphorus in pretreatment practices. That's how I understand the question. I don't know if that's true or not, but again, if we're thinking about pretreatment practices as increasing the ease of maintenance, increasing access for that, increasing the longevity of the individual practice, the structural BMP it's protecting, it's not going to have a numerical criteria related to its performance.
Okay.
Well, I think it'd be very difficult to put in numerical standards because they're always changing, especially with proprietary devices. And so you would have to go to each proprietary device and determine the numerical standards. You can go to a technique or a methodology like using Shazam to talk about numerical standards or continually updating that. But I think that would be difficult and possibly inappropriate for a stormwater manual to contain numerical standards on pre-treatment devices.
Right. That's why I stumbled a little bit on it because we don't have a lot of good information on it. We will never give credits or put efficiency numbers or things like that in the manual unless they've been thoroughly vetted, and a lot of this stuff has not been thoroughly vetted. And maybe that is a good opportunity for me to ask a question maybe for you, Scott, real quick. Not a question, but could you just real briefly explain the certification programs that are out there for folks that aren't familiar with them?
Actually, I might defer to John and Andy since they do some of the same testing at St. Anthony Falls. So.
Well, there is, as Scott mentioned earlier, there's the New Jersey DEP. They have a what's called NJCAT program. Out in Washington State on the West Coast, they have a TAPE program, TAPE, which is actually a field measurement system in general.
That's out of the state of Washington.
Out of the state of Washington, right? And then there are ASTM standards for some of these hydrodynamic separators and underground systems. I think there's a lab standard, and I can't remember if the field standard was also approved or not. But there are several standards for testing through the ASTM process. I feel like I'm missing some, but I don't know. Those are the main ones.
Those are the main ones, right.
So,
and you'll see, if you go to a manufacturer's website, you'll see if it's NJCAT certified or TAPE certified, oftentimes, because while it does cost money for the manufacturers to have them tested, oftentimes they want to build up that support for the use of those, at least in those states. And a lot of other states have adapted those same protocols, or at least the results from those, for acceptance.
And as Mike mentioned, that's that's something that gives them credibility in their products and that performance removal.
And we have some information in the manual on those programs, and I do get calls from folks saying, we've got this particular practice, and of course we have to be careful with working for public entity here about endorsing practices, but one of the questions I always ask is it certified? And if it's certified through TAPE or NJCAT or Shazam tested or whatever, we have a tendency to want to make sure that that information gets into the manual. If it has not been certified or tested through those programs, we're pretty reluctant to include that information.
Great. Thanks for all the responses. And that last question, from Craig, I hope that answered your question. If not, feel free to let us know. I think we're going to bring it back to Katie here.
Yep.
Okay.
Alrighty, so we started talking a little bit about sizing of these pretreatment practices here, and I'll speak briefly about some of the background on pretreatment across the country here, and then John will get into the details of the sizing that he's working up right now, these sizing recommendations. So pretreatment around the country, as part of this work order, we reviewed all 50 states' stormwater permits and actually a few territories just to see what was out there. We looked at stormwater manuals if they existed. A lot of the time, some of the larger, maybe less densely populated states really rely on their Department of Transportation to have to provide the stormwater or hydraulic design criteria for the state. So of the 50 states and 3 territories that we looked at, 47 had some sort of stormwater manual. 24 of those actually had some kind of detailed design criteria for pretreatment, meaning that it was at least one requirement, either a depth for a forebay, some sort of calculation for a volume, something to that effect. The rest of them either referenced other states or had really just general design recommendations like you shall provide pretreatment. And within what we did find, there was just a lot of variation in the standards too. So here's just a few pictures of some of the stormwater manuals that we dug up, and the Minnesota Stormwater Manual, the Wikipedia page actually does have a table here with some of these already on the page, so there's a link to that too. And then just to show the variation in sizing requirements and kind of recommendations, we just looked at a forebay as an example here. This is a just generic picture of a forebay design from the New Hampshire Stormwater Manual. And we look at forebays because they're really commonly used to provide some sort of pretreatment, and most people are familiar with them. This is I can't point with this. There's a forebay here on the left, providing pretreatment for just a generic structural BMP downstream, separated by a check dam, berm, or rock weir. So for the forebays, the dark blue states are the ones that had, again, some kind of detailed design criteria, at least one requirement. Had to be 4 feet deep, had to have some sort of certain volume or a specific surface area. The light blue states had just a general design requirement saying you should use a forebay. And then the gray states either just didn't have anything didn't specify anything on a statewide level. That doesn't mean that something doesn't exist, it just means that pretreatment for 4-bay was not explicitly required. Most likely it's required through an MS4 or some other local entity. So what we found was that there was a pretty good range of how you would calculate the size of a 4-bay. The most common one that we found was 1 inch of runoff from the impervious drainage area, contributing to the BMP itself. 0.1 inch, excuse me. There was also a percentage of the water quality volume going from 1 to 10%, or a percentage of the total volume, runoff volume going to the BMP itself, between 1 and 40%. And that really depended on what type of downstream structural BMP you had. If you had an infiltration device or an infiltration trench, particularly if it's underground, most states would require a higher percentage of that volume, so a larger 4-bay. And then Maine had this interesting one here that I liked, which was a pretty detailed equation to determine how much sand was actually going to enter into your 4-bay from your drainage area. Minnesota Stormwater Manual currently recommends 10% of the water quality volume, so 10% of 1 inch of runoff, and that it be between 4 and 6 feet deep. So I'll turn it over to John here to explain why sizing is important and what we're really working on here.
Thank you, Katie, and good morning. This is a work in progress. And so I only have one slide, but I'll tell you what we are working on. So why sizing is important? Well, there are many small treatment facilities like bioretention, biofiltration facilities, or what are called rain gardens, that do not have a pretreatment sizing criteria and are too small to justify hiring an engineer. I mean, you have some property owner putting in a rain garden in association with the city, and they're not going to hire an engineer to do that. They don't know how to have a pretreatment for their practice, and they don't even know that pretreatment is required. In addition, for larger pretreatment practices, we're talking about ponds, infiltration. For larger treatment practices, we're talking about ponds, infiltration basins, roadside swales, these types of things. They could use a preliminary design methodology for pretreatment. That's where you just want to have an idea as to what size you need. What size 4-bay do you need, for example? You want to have an idea before you go farther. This would be in a preliminary analysis. So what are we considering? We're developing this preliminary size criteria from the watershed, from these variables. First, you need the watershed's impermeable area, because pretreatment is mostly used and designed for smaller storms. That's the 1-year storm, the 2-year storm, everything smaller than that. You need the design storm intensity. That will be specified. You need the settling velocity of the targeted particle size. And so that's important. We have a way to calculate that. And then you need the fraction of that size to be removed. So you have to target a certain particle and a certain fraction to be removed. Otherwise, it doesn't work at all. And you can't really size your practice. So if we can determine the targeted particle size and the targeted density, for example, sand or silt, and the fraction of that size to be removed, for example, 80% to be removed in a pre-treatment practice, then we can come up with a size of the practice. So what will be the result? What will you need to size your practice? You need the area of the filter strip, or actually the sizing criteria will give you the area of the filter strip and the surface area of basins. We'll have recommendations on the depth of basins, because I think that's important, because you don't want to have everything scoured out. So you need to have a certain depth, but what the sizing criteria will give you is the surface area of the basin. And then from that, we make recommendations on the depth. Yeah, so that's it. It will be finished by the end of the month, and we'll have some discussions with the MPCA staff on how to incorporate this into the Stormwater Manual.
And just as a note, John and I and our engineers here have been communicating with each other, and John is doing some technical work behind this, using these parameters that he's talking about to develop this. But I think at the end of the day, what we're looking to have in the manual, the technical support information will be there too, but we also want to make sure that we have fairly simple, easy to interpret tools for folks to use, so that they can go in and say, well, I've got this type of practice, or I got this much impermeable area, or whatever, and to be able to generate the information fairly quickly, either tabular, graphically, or whatever the appropriate methodology for displaying that information is. And John, I don't know if you want to add anything to that, but as John mentioned, it is a work in progress, and we are communicating.
I guess I will. So Katie mentioned that there are a variety of different pre-treatment requirements required in terms of size, and that primarily is because people have been just taking a guess for the most part. I don't know if I should say that, but I believe that to be true. Looking at the different sizing criteria, people have just been taking a guess.
You can say it, I won't.
and using other manuals and putting what the other manuals have. If you go back and you follow that train of thought, you go to the original manual that came up with the concept of sizing, and they took a guess. And so we want to have something that has a little bit more engineering science behind it. We'll try and do our best.
We do think this is a really important topic, and as John alluded to, I'm not going to use the word guess, but we have heard from folks that they really don't know how to size the practices in a lot of cases, and so we're really looking forward to getting this information, and we think it'll be very useful.
And then with that, we'll just wrap up our webinar here by looking at a few of the pre-treatment case studies that we developed with some project sponsors. And we won't go through all of them. There's links to them at the end of the presentation here to the Stormwater Manual itself, but we'll just highlight the vegetative filter strip, rock filter strip, and 4-bay examples that were submitted. First off, though, I want to say thank you to all our project sponsors. This is just the ones that made the cut. There were others who definitely helped try to fill out information and get information back to us regarding their case studies for pre-treatment. But the Dakota County Soil and Water Conservation District, City of South St. Paul, City of St. Paul, Minnetonka Capital Region Watershed District, Mississippi Watershed Management Organization, City of Savage, City of Burnsville, New Brighton, and Fridley all had case studies that made the final cut. Shout out to Waconia and a few other cities who we tried to get something done on time, but we weren't able to make the final submittal. So our first case study here was not submitted by the City of Burnsville. It's a vegetated filter strip. It primarily provides pre-treatment from street runoff prior to entering a series of residential rain gardens. And you can see an example here on the left. So some of the lessons learned was that these filter strips have a lifespan of between 5 and 7 years, but the city firmly believes that they've maintained the lifespan and improved the maintenance, reduced the maintenance, of the rain gardens themselves. The filter strips have been replaced twice now over the last, I think, 10 years, Andy?
Roughly 10 to 15 years.
Due to accumulated sediment at the inlet there, but even with that, that's easier to replace the filter strips than to dig up the entire rain garden and all the plantings, remove the sediment there, and replace the vegetation. One of their lessons learned, too, was to incorporate drop waterfalls at the cutout to reduce the speed of runoff entering the rain garden and reduce erosion potential. Excuse me. Thank you. And then the City of Fridley and the Mississippi Watershed Management Organization partnered together to install these bioswales here, which are which treats stormwater runoff from the road entering via curb cutouts. You can see here at the lower part of the photo here is a rock filter strip. Some of the lessons learned from the city was that the placement of the rocks really matter, and blocked inlets were causing stormwater to bypass the basin themselves. Also, the size of the rocks, if they're too small, result in the rocks being carried away during large storm events. So through trial and error, they were able to determine that Class 1 riprap was the appropriate rock size for this specific bioswale, given the slopes and the flows entering these BMPs. Some of the other lessons learned that they recommended was that, obviously regular maintenance is key to the longevity of any BMP, but that is really prolong the lifespan of these treatment practices, and that they delegated the maintenance responsibilities. They actually added 3 years of maintenance responsibility to the contractor to ensure that the maintenance was conducted correctly and when needed. And they found that provided more consistent and better results than a resident-driven maintenance program. And then finally, we have the sediment forebay nominated by Dakota County Soil and Water Conservation District and the City of South St. Paul. Excuse me. The forebay cell here shown on the lower portion of the photo provides pretreatment for an iron-enhanced sand filter shown with the plantings on the more upper part of the photo. It's really hard to put out a laser pointer. One of the unique features of the sediment forebay is that they include turf stone pavers to facilitate sediment maintenance. Having a hard bottom at the bottom of your forebay really makes it easier for your contractor to go in and scoop out accumulated sediments, especially if they can't see the bottom. They also have level spreaders to distribute the flows evenly into the iron-enhanced sand filter. And this is a photo taken 4 years later, in 2016, prior to their maintenance dredging. The forebay had accumulated approximately 6 cubic yards of sediment and organic material, and actually had been experiencing some significant surface ponding. So some of the lessons from this particular practice was in areas with poor hydraulic soils or compacted soils, consider having underdrains to facilitate drainage and reduce the potential for surface ponding. And, excuse me, checking my notes here. And then also to vacuum the turf stone to remove the fine sediment that accumulates at the paver surface level after you remove the majority of the accumulated sediments. And like I said, the full case studies can be found in the Stormwater Manual. There's a link here. And that's it from us. Our contact information is shown here on the screen. If you have any questions, please don't hesitate to reach out to us or to Mike Trojan.
Do we have some other questions?
Okay, yeah, well, thanks to all the presenters today. We're going to go through our little chat box here to see if there are any more questions. It looks like we have a couple more questions. This one mentions Dr. Gulliver. You've mentioned that it is important to select the PSD or particle size on which to base the assessment of the pre-treatment device. On what PSD are the permit requirements based? The Stormwater Manual right now recommends a removal of 25% minimum. Is this based on the OK 110? 110, sorry if I butchered these acronyms, by the way, I'm not familiar. Yep, is this based on the OK 110 or the NURP? Let's see, there's a large difference between the two.
Well, I can't speak for the current Stormwater Manual. I'll turn that over to Mike Trojan, but simply sizing these things, you have to have a particle size and a percent removal. a typical particle size and percent removal would be to remove the 100 micron particles at roughly 80% removal during the design storm. And the design storm will have an intensity of about 0.5 inches per hour. That's the design storm. But I'll turn the manual question over to Mike here.
Actually, maybe I can, the 25% that's mentioned in the question comes from the previous work in the pre-treatment overview, and that's 25% of the 100 micron particle was kind of the suggested guidance for what we might expect a pre-treatment practice to do, given that we hadn't done the sizing criteria calculations yet. So what Dr. Gulliver is working on now will kind of help assist that. So that was just one recommendation, was 25% of 100 micron particles being captured in pre-treatment practices. It's not a requirement as far as I know, it's just a recommendation or even just a suggestion. But so it's not based on a particle size distribution, but a specific particle size.
So the permit does require pre-treatment, it doesn't specify what that is, and the manual has this 25% number in it, and all of that was fairly nebulous, and that's one of the reasons why we wrote these work orders. So hopefully we'll get some of that information clarified.
Okay, great, thank you. Next question here. Is there a particle distribution that is used as a guide for sizing the pre-treatment areas? To target a particle size and desired removal rate, is there help in determining an appropriate particle distribution, such as NURP 50?
Okay, yeah, this relates to particle size distribution. Thank you for that question. If you're going to use a dirt particle size, which is based upon actually settling velocities of sediments, translated, assuming that you have silica particles, which they didn't, assuming that you have silica particles into a sediment size, so I don't think it's appropriate. But if you're using the dirt particle size, you're going to remove very little in any pre-treatment practice, because that's a very small particle size distribution. The particle size distributions, the median diameter varies over at least 3 orders of magnitude depending upon the storm. That's why we are trying to avoid using a particle size distribution. For some particle size distributions, you're not going to remove any of your particles. For other particle size distributions, you remove most of your particles. I presume that in a big storm, it would be the larger particle size distributions. So that's why we have, and it varies at each site. You have big storms, you have small storms. And so why specify a particle size distribution when these practices are designed, these pre-treatment practices are designed to remove a certain size particle? And that's why we've chosen the 100 micron size particle with a certain percent removal. Please let me know if that does not answer your question.
That might make for a good topic to build a new page in the manual explaining that type of information.
Okay. Thanks for that response, Dr. Gulliver. Can you elaborate on experiences and applicability of internal weirs, isolation rows, and pre-treatment floor bays in underground stormwater systems used in detention, infiltration, and filtration systems around inlets? Also, is the 10% volume and 4 to 6 feet depth still relevant in these types of chamber systems?
I can answer the latter part of the question. Take the easy one. The 10% and 4 to 6 foot depth, that's really specific to a 4-bay providing pretreatment for a wet detention pond. So no, it is not applicable, I wouldn't say, for an underground chamber system. Want to tackle isolated roads?
I think kind of as Mike mentioned earlier with when you were talking about certifications and performance, the current guidance in the manual allows a lot of flexibility for people to choose a different device based on what they see in terms of performance. If there's measured performance on devices that have internal weirs or isolated rows or 4 bays or any other type of structural system in place, if that performance is documented either through a certification program or robust field monitoring or what have you, then that information goes in the manual and people can make a selection of those devices based on what they see as the right device for their site. At least that's how I understand the manual as being organized right now. In terms of experience and applicability, that's kind of what we've seen. If it's tested, it's published, then it's out there and you can use it. You still need to evaluate how it was measured, how that performance was measured. If it's not a certification program, it's good to evaluate that and make sure that it was a robust system of assessment, whether that's field monitoring or lab testing. But outside of that, it's really up to the user to evaluate that, look at it, and make a good selection for their sites.
Anyone else want to add to that? Well, that was actually the last of our questions. I know,
No, it wasn't.
no, I'm sorry. I guess we have some internal questions.
I have a couple things to follow up if there aren't any other questions online at this point. Certainly, people are free to submit more. We do have a little bit more time. I only have a couple slides to wrap up it, but I do have a couple comments here. One is Katie on the filter strips. The lifespan is 5 to 7 years. Is that assuming that proper O&M has been happening, and does that always mean replacement of the filter strip?
That is what the city of Burnsville experienced. I would say it probably is a good guideline, but would vary depending on site conditions. You know, if you have very steep roads, we're blessed in Minnesota, pretty flat. Other parts of the country are pretty steep, so you may experience more loading going into your filter strip that would reduce your maintenance cycles. You may not prolong it to 7 years. What was the latter part of the question? Excuse me.
No, I think you answered,
Okay.
answered it there. And then maybe this one's for Dr. Struck, is the O&M, because there's so many practices and they're so different and so forth, the O&M info tends, in the manual, I believe there's generally links, isn't there, to the O&M information for these practices?
That's correct, and kind of like the question to Katie with the vegetative filter strips, you know, there's so many factors that contribute to O&M. I think the most critical piece is actually the inspection side, looking at it, seeing if it needs maintenance, and then following up on a maintenance protocol if it's a proprietary device from a vendor, and if it's a non-proprietary device, you know, typically we try to include a maintenance guidance when they're in the design phase. So going back to that operation maintenance manual, but I think the big piece of that is that inspection frequency and actually looking at it, making sure it's functioning as designed, and because there are so many factors. I mean, it can be as simple as a construction site that happens to have exposed soils, and you get in a big major event that can, you know, in one event you can fill up your BMP or your pre-treatment and have it rendered non-functional. And
have you found the O&M guidance for these practices to be pretty much right on the ball, or?
I would say that they have a generalized O&M protocol that they have, and so their inspection frequency, and this is included in some of those tables that we have in the manual and the filtering tool, they might be, for instance, recommendations for monthly inspection or quarterly inspection or semi-annual or annual, which sounds frequent, but remember, that doesn't necessarily mean that it's maintenance every time. It's looking at it to see if it requires maintenance at that time. Some even require, or suggest anyway, that it's after a major storm event, because that's, from a risk perspective, that's more likely when you'll have the greatest chance of it filling up with something, with sediment, or, and the thing is that it doesn't always have to be, for instance, sediment in this. It could be a pop can or you know, a plastic bottle or something like that can cause it to be non-functional. So sometimes it requires just an inspection, a simple looking at it. And I think that's the challenge sometimes with the underground facilities, is sometimes it's out of sight and out of mind, and you don't actually go and lift the manhole cover or the inspection port until the manual says to do it, you know, every year. And so sometimes you might not realize that it isn't as functioning nearly as well as what it probably should have been. And so that frequency of inspection, I think, is one of the most important aspects of the O&M.
Yeah, we got a couple more. Looks like we may have missed a question from Daniel. Daniel, we apologize. You know, we're scrolling through this text box, so it's really easy to miss some questions. But if you wouldn't mind retyping your question as we address another question here, we can certainly get around to yours. So question here, how was the maintenance frequency evaluated in the pre-treatment selection tool?
So for the most part, we took the information right off of the manufacturer's website that recommended a certain frequency or some guidance in that frequency, and included that information. So that was certainly the case for proprietary devices. For non-proprietary devices, we use kind of a general rule of thumb, which is probably going more on what Dr. Gulliver was describing in terms of, you know, how they're designed and the settling velocities and the potential accumulation that can occur within those. So, you know, there's some flexibility in the design. So, for instance, if you're designing a deep sump, well, what does deep mean? It can be, you know, 4 feet or it can be 12 feet, and that has a different capacity for holding sediments. So a lot of it has to be, you know, based on the individual practice itself. And so we didn't go into too much detail on it because of that, the variability in design, but we gave kind of a general rule of thumb.
Great. I think this one might be for you as well, Dr. Streck. Where is the link for the pre-treatment tool?
Aha, that's a great question. We have not included it yet because we have some final cleanup and just some things, some testing to do internally with the team. And even that, some of that includes nomenclature, et cetera, that we're using it within it. It will be provided by the end of the month, for sure.
And if I understand correctly, we'll also have the ability to continue updating it beyond that, so that as more practices come online, and that we'll be able to continue to build on that tool.
That's right. So we're again, in terms of that, the maintenance of the tool itself, we're giving that over to Mike and MPCA so that they have control over and can maintain it themselves in the future.
So I don't know if there are any other questions. We're going to unfortunately have to defer those, but we will try to get to all the questions in a posting that we'll have in the manual. So I didn't go through the pre-treatment stuff. There were some great screenshots to show you what is in the manual right now. So just, if you're in the manual, just type pre-treatment in the search box and it'll be the site that pops up. A note, and it's been mentioned a couple times, that this current work order ends July 1, so things are still in flux. We're still adding things to the manual. The selection tool is still being worked on. The sizing information is still being worked on. So we still have some work to do, so keep that in mind. But at the bottom of pages in the manual, there is a comment box. If you have comments, please send them to us. I do read those first thing Monday morning. I can't wait all weekend. I just wait to get in and take a look at the comment box. So I'm always disappointed when there's nothing there. If you're in the manual, just as a point, a little self-promotion here. On the left, there's a toolbar, and you'll see 3 things that we would encourage you to look at occasionally. A What's New section, these are things that we have updated in the manual. Future updates, these are things that we're working on. And then an events page, which we encourage you to go to, and if you know of events, please send them to us and we'll try to get them posted. All materials will be posted in the Stormwater Manual as soon as we can get them in there. The PowerPoints, I believe, are in there already, and the certification information's in there, and we'll try to get the other stuff in there as quickly as we can. Does anybody else have anything to add?
I have a question for you. Since you have events coming up, do you have an advertisement for the Stormwater Operation and Maintenance Conference that will be here in Minneapolis first week in August. And my colleagues around the table are quite involved with planning that.
Yep, it is on our events page, and we even have a picture off the website for the conference. And yeah, I should say, please do go to the events page, and we're really looking forward to that O&M conference. There's some really great speakers and presentations coming up. Unfortunately, one of them probably won't be the one I'm giving on the last day, but by that time, most people will be gone anyway, so. Anybody have anything to add? Well, I'd like to thank very much our speakers again. I didn't get a chance to read their bios. I thought maybe Katie and I maybe miscommunicated a little bit on that. But I can post them because they're very illustrious people that we had here today. So thank you and enjoy the rest of your day.
And Mike, if you didn't already mention, this is recorded, so.
It is recorded. Thanks.
It's recorded. It should be available soon enough. Yeah. Thanks, everyone.
You got a box in the middle.
Oh.